Hi dear children, today we are going to discuss Wheatstone bridge. So here Wheatstone bridge is nothing but the applications of Kirchhoff's laws. Okay, so to verify that we have to consider four resistor. One is P and another one is Q and R and S. So four resistor we have connected across the point A, B, C and D. Okay, now we have to apply, there is a potential E in between A and C. In between A and C we have introduced, there is a potential E, and through this there is a current, I amount of current will be passes through in this circuit. Okay, now when the current I is reaches point A, this current will be divided into two portions. Okay, so it is divided into two, and one is denoted in terms of I1 and another one will be denoted in terms of I2. Okay, so now this I1 is reaches B. After reaching B, this will be divided further into two. Okay, again this I1 will be divided into two half. So one is I3 and another one will be denoted in terms of Ig. Okay, why here we have denoted in terms of Ig? Because this is the current which is passes through in the galvanometer. So here we have introduced the galvanometer, a sensitive galvanometer in between the point B and D. Okay, so now this is the amount of current will be passes through in the galvanometer, and this will be denoted in terms of Ig. Now this I2, okay, so this I2 when it reaches point D, this Ig and this I2, okay, Ig and I2 is joined together at the point D, and then it will be passes through across S. Okay, and this will be denoted in terms of I4. Okay, now this I3 and I4 will join together at the point C, and through this once again the same amount of current which is passes near A, the same amount of current will be coming to the negative end of the terminal. So this is the description of the diagram. Now first of all we have to apply the Kirchhoff's first rule at the junction. Okay, junction B and D. Okay, so here we have to apply a Kirchhoff's first law. Okay, so here we have to apply a first law at the junction B and D. Okay, so what is the Kirchhoff's first law? Okay, the first law states that the algebraic sum of the current passing or the algebraic sum of the current meeting at the junction, it becomes zero. The algebraic sum of the current meeting at the junction, it becomes zero. So now we have to consider the point P. Okay, at this point what are the current will be involved? We have three current is involved at the junction B. So first at junction B, I1 current will be involved, then Ig current, then I3 current. Okay, so these are the three current is meeting at the junction B, and the algebraic sum of these three is equal to 0, which is equal to 0. Now here we have to apply the sine function. So how can we introduce the sine function? Very simple. When the current is meeting the junction, okay, when the current is meeting the junction, that current will be denoted in terms of positive value. So I1 it become positive. Then when the current is leaving the junction, when the current is leaving the junction, and this will be denoted negative symbol. Okay, so when the current is meeting the junction, it takes a positive. When the current is leaving the junction, and those current will be taken in terms of negative value. So now I1 minus Ig minus I3 which is equal to 0, and this is equation number 1. Okay, next we have to apply the same law at the junction D. Okay, next junction D. Okay, at junction D, the same law only we have to apply at junction D. Okay, so here junction D, okay, and this is junction D. So now we can see in junction D what are the current will be involved: I3, I2, Ig, I4. So here you have to write I2, then Ig, then I4, which is equal to 0. Okay. So now here what is the sign for I2? This I2 is meeting the junction. Okay, it's going towards the junction. The same way Ig also is meeting toward the junction, is coming to the junction. So these two values is taken in terms of positive value. And I4 is leaving the junction, and this will be denoted in terms of negative. Okay, now this is equation number 2. And next we have to apply Kirchhoff's second law. So what is the second law? Second law states that the amount of EMF, okay, or the product of current and the resistance involved in the circuit is equal to the algebraic sum of the EMF involved in the circuit. Okay, the algebraic sum of product of current and the resistance is equal to the algebraic sum of the EMF involved in the circuit. Now here we have to take two closed circuit. Okay, so because the second law we have to apply inside the closed circuit. So now we have to take in terms of two closed circuit. So one is nothing but A, B, C, D. So this is one closed circuit. Then another one closed circuit A, B, D, A. Okay, so here we have to consider two closed circuit. So one is nothing but A, B, D, A, and another one is A, B, C, D. Okay, so now we have to apply first the closed circuit. Okay, closed circuit A, B, D, then A. Okay, so in this closed circuit we have to apply the second law. So I1 P, then Ig, okay, Ig G, then I2 R, which is equal to 0. Why it becomes 0? Because there won't be any potential is applied or any battery. Okay, so no battery is connected in between this closed circuit. So out of this closed circuit only the potential is involved. Within this closed circuit A, B, D, A, there won't be any potential is involved, there won't be any battery is involved. So the algebraic sum of the EMF will become 0. Now here we have to apply the sine function. Okay, so here we have to apply the sine function. How can we give the sine value? If the current is passing in clockwise direction, we have to represent in terms of positive value. So I1P is nothing but clockwise direction, so that it is denoted in terms of positive value. Then IgG, okay, IgG also it is moving in terms of clockwise direction, so that it is also a positive. Then here the current has to supposed to passes across DA direction, but here actually the current is passes from A to D in anti-clockwise direction. The current is passes, so that it is denoted in terms of negative. Okay, so now this will be represented in terms of equation number 3. Next, the same way, the same second law we have to apply in closed. Okay, closed circuit. Okay, closed circuit A, B, C, D, A. So in this closed circuit, next we have to apply the Kirchhoff's second law. So when you apply this Kirchhoff's second law, you will get I1P, then I3 Q, then I2 R, then I4 S. Okay, which is equal to 0, because within this closed circuit there won't be any battery is involved, so that the algebraic sum of the EMF will become 0 once again. Okay, and this is equation number 4. Now we have to introduce the sine function. Okay, so now here we have to introduce the sine value. So as I said earlier, when the current is passes in terms of clockwise direction, we have to represent in terms of positive value. So I1P it is a positive, then I3Q also it is a positive, then I2R it is a negative because it is moving in anti-clockwise direction. The same way I4S also it is a negative. Okay, and this is the fourth equation. Now we have to introduce one special condition. So what is that special condition? Very simple. Okay, when this galvanometer shows zero deflection, when the galvanometer shows zero deflection, when the potential experienced at B as well as D it become equal. Okay, the potential developed or the potential experienced at B as well as D is equal, then the galvanometer shows zero deflection. Okay, now or otherwise we can say that the flow of current through this galvanometer which is equal to zero. Okay, suppose if Ig which is equal to 0, okay, we have to introduce the condition. So when this Ig which is equal to 0, when the potential across B and D it becomes 0. Okay, are same. Okay, B and D are same. There is a current which is passes through across the galvanometer, it becomes 0. Right. Now this condition we have to apply in equation number 1, 2 and 3. Okay, so we have to apply this condition in equation number 1, 2, 3, and then we have to rearrange. Then we have to substitute the resultant value in equation number 4. So by applying this condition in 1, 2, 3, okay, so substitute in 1, 2, 3, we will get, for example, this Ig. Here when you substitute, Ig is equal to 0. If you substitute 0, what will be the first equation? The first equation will become I1, okay, I1 minus I3 which is equal to 0, which implies I1 which is equal to I3. Okay, and this is equation number 5. Okay, so this negative value is bringing to the right hand side, then it becomes positive value. And the same way here we have to substitute Ig becomes 0. Then this equation is rewritten like this: I2, okay, I2 minus I4 which is equal to 0, which implies here I2 which is equal to I4, and this is equation number 6. Okay, this is equation number 6. When you substitute here Ig which is equal to 0, 0 into anything, the value will become 0. Then this equation will be rewritten like this: how I1P, okay, I1P minus I2R, okay, which is equal to 0. Now this negative value we can bring it to the right hand side. Then it implies, okay, I1P which is equal to I2, okay, I2R. So now this is equation number 7. Okay. Now this 5, 6, 7. So these three equations we have to substitute in equation number 4. Okay. I hope up to this step you can able to understand. And now we have to substitute these conditions in equation number 4. What is that equation number 4? Once again I will write this equation number 4 here. So I1P plus I3Q minus I2R minus I4S, okay, which is equal to 0. Right. And this also I will write it. Right. Okay, so this is the fourth equation. Okay, this is the fourth equation. Now we have to substitute. Okay, substitute equation 5, 6 and 7 in equation number 4. When you substitute, what will be the certain value? Here you will get I1P. So instead of this I3, okay, instead of this I3, okay, so we have to substitute. Okay, so instead of this I3, once again we have to write I1Q, because I1 is equal to I3. So instead of this I3, we have to substitute I1. Then here minus I2R minus I2, which is equal to I4. So instead of this I4, we have to write I2, which is I2 yes, which is equal to 0. Now from this, okay, so from this 2, we have to take I1 as a common value. So I1 P plus Q. Okay, same way here we have to take minus I2. Okay, so we have to take minus I2 as a common value. So what will be the remaining? R plus S. Okay, which is equal to 0. R plus S, which is equal to 0. Now after this we have to bring this I2 to the right hand side. Then I1 P plus Q, which is equal to I2 R plus S. And this is equation number 8. So this is the 7th equation and this is the 8th equation. Now 8th equation is divided by 7th equation. So 8 divided by 7. Okay. So if you divide, what will be the answer? I1 P plus Q, okay, divided by left hand side we will have I1 P, okay, that which is equal to I2 R plus S divided by I2 R, okay, I2 R. Now here I1 get cancelled, then I2 will be get cancelled. Okay, so what will be the next step? It's very simple. So P plus Q divided by P, which is equal to R plus S divided by R. Okay. So now what we have to do is we have to split, okay, this equation. So P divided by P plus Q divided by P, which is equal to R divided by R plus S divided by R. Then P, R will be get cancelled. Then what about the remaining? So which implies 1 plus Q divided by P, which is equal to 1 plus S divided by R. Suppose this one is bringing to the left hand side or this one is bringing to the right hand side. Okay, the plus one it become minus. So minus into minus 1 and plus 1 it becomes 0. So we have to remove this one. Okay, both the side that 1 will be removed. And what will be the remaining? Q divided by P, which is equal to S divided by R. Okay, or this equation will be rewritten like this. Okay, P by Q, which is equal to R by S. So out of this 4 resistor, if you know any 3, okay, 3 value of a resistor, okay, if you know the value of 3 resistor, the 4th one unknown resistor we can able to calculate. By using this Wheatstone bridge, we can able to calculate the unknown resistance of the resistor. So this is one of the important 5 mark question. You please take a note and you can go through. If you have any doubt at any time, you can contact me and you can clarify your doubts. Thank you.